move on to a different kind of solution, a solution which is not an acid, not a base, but it's a salt solution. Say a solution of NaCl, a solution of CH3COONa, a solution of say NH4Cl. These are all salts, right? If I take a pure salt like NaCl or sodium acetate or ammonium chloride, if I take up any of this salt, will I get a pH of the solution which is not 7? Will it be alkaline? Will it be acidic? Will the solution have a pH not 7? After all, these are pure salts. So you have to analyze that. And you can see what I have done over here is I have listed 3 salts which are of 3 kinds. NaCl, one may say any salt is made up of or has been created by a reaction of an acid and a base. So if I think of the acid and the base, it is HCl and NaOH, right? So it's a salt of a strong acid reacted with a strong base, right? So in this particular case, it is HCl reacted with NaOH. When I do this reaction, I'll end up with NaCl and water. So I'll say the salt or the solution is a NaCl solution. Even though you don't have a NaCl molecule in the solution as such, but we say that the solution, salt solution, is NaCl solution. We'll write the ionic equation in a while. And what about this one? Again, it's a acid-base reaction. So what is the associated acid? So the acid is CH3COOH, acetic acid, right? So it's a weak acid, right? Weak acid reacted with a strong base, and that is NaOH. So similarly, this one is a reaction of a weak base, which is NH4OH, when reacted with a strong acid, which is HCl. Mind you, exact amount of NH4OH, exact number of molecules of NH4OH reacting with exact same number of molecules of HCl is going to give you NH4Cl salt, and all of base and acid is consumed. So then only you get that salt. So if a strong acid and a weak base has reacted, or a weak acid and a strong base has reacted, or a strong acid and a strong base has reacted, or I like the fourth kind also, weak acid and weak base, if they have reacted, you'll create a salt, something like CH3COONH4, right, which is acetic acid and ammonium hydroxide. So the weak acid over here is acetic acid, and the weak base over here is ammonium hydroxide. And if they react in equal quantities, it is going to give this salt. Now this part of the chapter, we are going to analyze the salt solution, the salt alone. So we are just naming the salts as a product of a weak acid and a strong base, or weak base, strong acid, and the other kinds. We are just naming it like that, but it is a section which is dealing with pure salt. Pure salt, I'll just write pure salt. Not a mixture of salt and some acid or something. Pure salt. So why would a pure salt give a pH, a pure salt solution have a pH not equal to 7? The pH may not be equal to 7. You can see the reason over here. You can see that if you have a pure salt which was due to, or the genesis of the pure salt was because of a reaction of a weak acid and a strong base, then obviously we expect the solution to be basic, right? And the pH more than 7, right? And in case of a strong acid and weak base, we would expect that when say HCl reacts with NH4OH, even though they are equal amounts, say 10 moles of HCl has reacted with 10 moles of NH4OH, we would expect the solution to be acidic. Why? Because HCl is more acidic than NH4OH. So if they have the same number of moles reacting, still we would expect the solution to be acidic. So now the question arises that had there been no acid and base reaction, if I take up the salt, if I take up NH4Cl and I dissolve in water, will I get any reaction? And due to that reaction, will the solution be rendered as acidic or basic. So this part, the reaction of a salt with water, reaction of a salt with water, is called hydrolysis. Hydrolysis of the salt. The salt is actually reacting with water and something is going to happen. So before we go on to do the hydrolysis of each of these four kinds of salts, let us have some basics clear. And what is that? Any salt, any salt if dissolved in water, it will completely ionize. What do I mean by this? If it is any salt, say NaCl, CH3CO, Na, NH4Cl, CH3CO, NH4, even though it's a salt of a weak acid and a weak base, doesn't matter. When dissolved in water, it is going to fully ionize. It is going to give you the cation and the anion completely. So if I have, say, 3 moles of any of these four salts, and let me just call the salt as Ba, it is completely going to give me B plus and A minus. No equilibrium over here. No equilibrium. It is completely going to ionize. So if you have 3 moles, all 3 moles of this is gone. So you don't have the salt in water at all. There is no salt in water. There is there are these ions, and these ions are going to do their own drama, but there is no salt in water. There is no salt molecule in water. I hope it is clear. So when I say I have a salt solution of CH3CONa, do I have a CH3COONa molecule in water? Do I have this complete molecule in water? Do I have a NH4Cl molecule in water? If I say I have a ammonium chloride solution, if I say ammonium acetate solution is there, do I have this complete molecule in water? The answer is a big no. You don't have salt molecules. You have salt molecules when they are not dissolved. When you have dry powders, dry crystals, or whatever. So when they are not dissolved, in a way you can say you have molecules. In fact, you have multiple molecules all joined together. You'll be doing that in solid state later on. But in no case can you say that there is a molecule of NaCl or sodium acetate. You can't say these molecules are there in a aqueous solution. You don't have salt molecules in aqueous solution. In a solid state, in their powder form or in their crystalline form, you have clusters of NaCl, you have clusters of sodium acetate, you have chains of them, and we'll be studying how they are attached in a different chapter. But the point over here in this chapter is there is no molecule of a salt which is dissolved in water. It is another question whether a salt got dissolved or not. If I have a salt, say Ba, and it doesn't dissolve, it remains solid, it doesn't dissolve, then that's okay. You can have the solid thing, and then there is cluster of molecules which are all cations and anions. They are just arranged beautifully and sticking to each other in a certain pattern. That's a solid. That's the solid state. But we don't have Ba molecule in the aqueous state. This doesn't make any sense. This is nothing but this is nothing. It is Ba plus aqueous and A minus aqueous. You don't have this complete molecule. I hope you get it. So what I'm trying to say is, in a beaker, you may have a salt which doesn't dissolve, or only part of it dissolve. Out of 1,000 of it, say 999 remain, or 10,000, 9,999 remain, and one dissolves. Then that one doesn't exist. This becomes zero, and this is what exists: one of this, and 999 of solid will remain. But there is no molecule of Ba floating in water. There's water and you don't have a Ba molecule floating. I hope that is clear. whether the salt was from a weak acid or a weak base or a combination of weak acid, weak base, we don't care about it. A salt as a molecule will not exist. I hope that part is clear. So let us start with the first kind of salt, which is from a strong acid and strong base.